Dear students, I am Ramesh, chemistry faculty from Vidya Mandir Metric Higher Secondary School, Uttangarai. Now, in this session, we may discuss 12th syllabus solid state. Listen, here we are discussing that is crystal lattice first. So, first one, it is crystal lattice. Crystal lattice. Now, what do you mean by crystal lattice? It is a regular arrangement of atoms or ions or molecule in a three-dimensional pattern. So, crystal lattice is considered as a regular arrangement of atoms or ions or molecules. Atoms or ions or molecules in three-dimensional pattern. Three-dimensional pattern, which is known as crystal lattice. Now, we may take the second one. It is unit cell. Unit cell. Now, what do you mean by unit cell? And unit cell is the basic fundamental repeating units in a crystal lattice. So, here the unit cells are the basic fundamental repeating units in crystal lattice. Is called as unit cell. For example, we are taking here a brick. Consider a brick. If a brick is a unit cell, then the wall is a crystal lattice. So, here the unit cell considered as a brick. Then the crystal lattice is wall. So, each unit cell is connected with one another, correct? Each unit cell is connected with one another. Then we are getting a bigger wall. Now, we may take the characteristics of unit cell. Listen, here the characteristics of unit cell. So, we are taking characteristics. Of unit cell. Characteristics of unit cell. Now, if we are taking the unit cell, listen, it is considered as a unit cell. A cube. I am taking a cube is a unit cell. It is a unit cell. Okay. Now, in a cube, we are called corners. What is it? These points are called as corners. So, these are all corners. So, how many corners are there? So, how many corners? 1, 2, 3, 4, 5, 6, 7, 8. So, these are all called as corners. So, how many corners? So, corners are 8. So, there are 8 corners in a unit cell, in a cube. Cube is considered as a unit cell. Now, how many phases? We are taking phases. Now, what is it phases? Listen, here it is a one phase. This is considered as one phase. Correct? It is one phase. Then the back, here it is a phase. Another one phase. Correct? It is the dotted line. This is the second phase. So, first and the second. Now, the third one, this, and fourth one. 5 and 6. Correct? Now, if you are taken the phases, the first phase, we are numbering it here. What is it? The first phase 3, 4, 7, 8. This is the first phase. Then 1, 2, 5, 6. This is the second phase. Now 1, 2, 3, 4. This is the third phase. Now 5, 6, 7, 8. It is the fourth phases. Now fifth phases. What is it? 1, 3, 5, 7. Correct? Then the sixth phases 2, 4, 6, 8. So how many phases are there? There are 6 phases. There are 6 phases. Now we may take that body centered. Body centered. And how many body center? It is the center of all the corners. So only one body centered. So we are taking that in a unit cell, we are take 8 corners and 6 faces and one body centered. Now we may take that is edges. What is that? Edges. And how many edges are there? What do you mean by edges? 2 faces are ending, then it is considered as a edges. So there are 12 edges are there. We may soon later. So there are 12 edges. Okay. So these are the characteristics of unit cell. Now the corners, faces, body centered and edge centered, they are called as lattice points. Lattice points. So here the atoms or ions or molecule occupy in a crystal. So in a crystal, the atoms or maybe ions or maybe molecule is present only at these corners, faces and body center, then which is considered as primitive cells. Okay. Now other than this, we are considered this one, we are taking, this is a face centered cubic. We are taking face centered cubic. Listen, consider a cube. Now it is considered as a unit cell. Okay. Now we are taking unit cell and crystal lattice. Now this is the one unit cell. So many unit cells are arranged in a 3-dimensional way. Then it is known as crystal lattice. Now we are considered that is total one unit cell. Now it is, listen, there are 6 phases. What are the 6 phases? 1 and 2, 3, 4, 5 and 6. So that front and back 2 phases and left side and right side it is 2 phases and top and bottom. There are 6 phases. Now we may take the corner atom. Listen, if we are taking a corner, how many corner? Here 1 corner and 2, 3, 4. Then same way the back side 5, 6, 7, 8. So totally there are 8 corners. Correct? Now we are taking edges. Now 2 faces are meet at the edges. Listen, if you are taking 2 faces. Now it is orange face and blue face. And this orange face and blue face is meet at the edges. This is considered as a edges. Correct? So how many edges are there? Here 1. Correct? Here 1 and 2. 3, 4. The same way back side 5, 6, 7 and 8. Okay. So 1, here 1, 2, 3, 4, 5, 6, 7, 8 and 9, 10, 11, 12 in the bottom. We are taking here. These 2 are edges. So there are 12 edges and 6 faces and 8 corners. Now we may classify the unit cell. So we are take unit cell. Unit cells are classified into two types. There are two types of unit cell. One is primitive unit cell and non-primitive unit cell. It is primitive unit cell and non-primitive unit cell. Listen, what are primitive unit cells? Here, the primitive unit cells are only the corner atoms are occupied. So, we are take the corner atoms are occupied. The atoms or ions or molecule is present only at the corner. Then it is known as primitive. So, we are considered as a cube. Then it is only the corner atom. So, here 1, 2, 3, 4, 5, 6, 7, 8. So, only the 8 corner atoms are occupied. Then it is considered as primitive. And there are 7 types of primitive. 7 types of primitive unit cell. 7 types of primitive unit cells in a crystal system. Now, we may take non-primitive. Now, a non-primitive unit cell is one. The atoms or ions or molecule is present at the corner in additional to the face center and the body center and that end center. So listen, here this is the cube. Here it is a cube. Now how many corners are there? There are 8 corners. And in this additional 2 corners, there is a body center. Now it is body center. So it is considered as body centered cubic. Body centered cubic unit cell. So in additional 2 corners, the body center is also occupied. Then it is known as body centered cubic. Now we are take, that is another one, we are considered the unit cell. Here a unit cell, and in additional to corner, face centered atoms are present. Now it is one face, then it is face centered, correct? Then another face, it is face centered. Then here one face, it is face centered. And here one face, it is face centered. So how many faces are there? There are 6 faces. Now I am filled up only with 4 faces. Now listen, if we have taken this face, listen, it is one face, correct? This face centered atom, now it is the center, so it is a 5th one, correct? Now another one face, we may consider this one. Here it is another one face, correct? The dotted one, it is back. And the center atom here, it is another one face center. So how many atoms are present? There are 6 atoms that will be present at that face center. So 6 faces and 6 face centered atom. Now it is considered as face centered cube. Face centered cube. And another one is that, then it is end center. So listen, we are taking, that is end center. What is it? End center. So end center atoms are one. Here, that is all those corners atoms are present. All those corner atoms are present. And out of 6 faces, only 2 faces are filled. So here 1 and here 1. So 2 faces are filled, then we are taking that it is end center. In these faces, there may be 1 or 2 atoms are there. Now it is considered as end center cubic. That is ECC, end center. And in your book, it is considered as basis of face center. It is considered as basis of face center. Basis of face center. So in your book they are considered. So what are non-primitive? Non-primitive unit cell is one. In additional to corner, it may be body centered or face centered or end center atoms are present. Now here in FCC, in additional to this face center, there are 8 corners, correct? So there are 8 corners and 6 faces are occupied. Then it is face centered and body centered. It is 8 corner and 1 body centered is occupied and end center. And here it is 8 corners and 2 faces are occupied out of 6 faces. Now consider a unit cell. Here take unit cell. Listen, we are taking a unit cell. It is a unit cell. Now, it is arranged in X and Y and Z axis in a 3-dimensional. Now, it is in that X axis. And here, it is in that Y axis. Now, it is in a Z axis. So, 3-dimensional way. Now, we are taking, these are all edge length. We are considered as a edge length. So, here the edge length A and the edge length B and the edge length it is C, correct? So, these are all intercepts and it is considered as a edge length. Okay. Now, here there is a interfacial angle or crystallographic angle. Now, ABC are edge length. Edge length. Now, we are taking here it is alpha, here it is beta, here it is gamma. So, alpha, beta, gamma. They are considered as crystallographic angle. Crystallographic angle. Now, we are taking the types of primitive system. How many types? There are 7 types of crystal system. Then they are considered as only the primitive. What do you mean by primitive? Only the corner atoms are filled. Now, depending upon, there are 7 types of crystal system. So here the types of crystal system. Types of crystal system. So how many types? There are 7 types and they are 1. It is simple cubic. So we are considered as cubic. What is that? Cubic. And the second one, it is rhombohedral. Rhombohedral. So rhombohedral. And the third one, it is hexagonal. Hexagonal. Then the fourth one, that is tetragonal. So it is tetragonal. Then the fifth one, it is orthorhombic. Orthorhombic. And the sixth one, monoclinic. Monoclinic. And the seventh one, that is triclinic. Monoclinic and triclinic. Listen. Here, depending upon these A, B, C and alpha, beta, gamma, the edge length and that the crystallographic angle, we are considered as 7 types of crystal system. Now, here we may take a cubic. If it is a cubic, then the edge length A is equal to B is equal to C. So, edge length all are equal. Now, The crystallographic angle, that is alpha, is equal to beta and it is equal to gamma and it is 90 degrees. It is equal to 90 degree. Then it is cubic system. Now, if it is a rhombohedral, that is A is equal to B is equal to C. All the echelons are equal. Now, here alpha is equal to beta is equal to gamma and here it is not equal to 90 degrees. So, if it is a cubic, echelons are equal and all the angles are equal. Now, if it is a rhombohedral, echelons are equal and all the angles are not equal to 90 degree. Now, if it is a hexagonal. Now, hexagonal A is equal to B and B is not equal to C. A is equal to B and B is not equal to C. And here, that is alpha is equal to beta, which is equal to 90 degree. 90 degree and gamma is 120 degree. Gamma is 120 degree. Now, if it is a tetragonal, A is equal to B and which is equal to C and here there is not equal. These two are same. A equal to B, B is not equal to C. And here alpha and beta and that gamma which is equal to 90 degree. Which is equal to 90 degree. Now orthorhombic and here A is not equal to B is not equal to C. And here alpha, beta and gamma equal to 90 degree. Alpha, beta, gamma is equal to 90 degree. And if it is a monoclinic, A is equal to not equal to B and it is not equal to C. And here alpha equal to gamma which is equal to 90 degree. And beta is not equal to 90 degree. Beta is not equal to 90 degree. Now, if it is a triclinic, here A is not equal to B is not equal to C. And here alpha is not equal to beta is not equal to gamma. So, depending upon the edge length ABC and the crystallographic angle alpha, beta, gamma, we classify 7 types of crystal system. They are cubic, rhombohedral, hexagonal, tetragonal, orthorhombic, monoclinic and triclinic. Okay. And how will you easily memorize it? Listen, first is A equal to B equal to C and all are equal. Now it is equal, it is not equal to 90. And after that, these two are same, correct? B is not equal to C, B is not equal to C. Now, here it is different. Hexagonal is alpha, beta 90 degree and gamma 120. And here orthorhombic. Here that is orthorhombic and monoclinic and triclinic. All are A is not equal to B, B is not equal to C. All three cases not equal to B and C. And here the triclinic all are not equal. So likewise we may memorize it. And then next one, here the cubic one, we are taking that these are all only primitive cells. What are primitive cells? That is corner atoms are filled. In additional to primitive, the body centered atom or face centered atom or end centered atoms is filled, then it is considered as non-primitive cells. So here it is done by Brevis. So according to Brevis, there are 14 crystal system. 14 crystal system. And here only 7. And another 7s are here, if it is a cubic, it is primitive, and in additional to primitive, it is body centered cubic. Body centered cubic. And in all cases, primitive unit cells are common. Primitives are common. So here 1, 2, 3, 4, 5, 6, 7 primitive unit cells are there. So here it is primitive, and here also it is primitive unit cell is alone, and here the fourth one tetragonal. And in tetragonal, that is primitive unit cells are present, and primitive unit cell, that is BCC, body centered, and also face centered cubic is in additional. Now, if it is a orthorhombic, here it is primitive, and also that here face centered cubic, body centered cubic, and end centered cubic. End centered cubic. Now, if it is a monoclinic, here also it is a primitive unit cell and also end-centered cubic. End-centered cubic is otherwise known as basis of face center, and here it is only primitive. So, here there are 14 types of Brevis crystal system. So, crystal systems, both primitive and non-primitive, are 14. Only the primitive, then we are considered only the 7. Listen, here we may calculate number of atom per unit cell. So first we may take, that is a simple cubic cell. That is simple cubic cell. What do you mean by simple cubic cell? We are taking only the corner atom. It is a primitive cell. And a simple cubic unit cell is one, only the corner atoms are occupied. So here only the corner atoms. So here we are taking 8 corner atoms. So the atoms or ions or molecule is present only the corners. Then it is considered as simple cubic. Now, so here corner atoms are occupied. Only that corner atoms are occupied. Corner atoms are occupied. Okay. Listen. Here one corner atom is shared by how many unit cell? Listen, we are taking, this is one corner atom. And here each corner atoms are touches with each other. So the corner atoms are touch with each other through that edges. Okay. Now here the coordination number. So coordination number of simple cubic is 6. What is the coordination number? The number of nearest neighbors surrounding in a particular atom is known as coordination number. And it is only in a 3-dimensional way we may identify simple cubic. If body-centered cubic we may explain coordination number. Okay. And we are taking the next one, number of atom per unit cell. Now, in a simple cubic, how many corners? It is 8 corners. And 1 atom per unit cell. So, we may take one corner atom is shared by 8 other unit cell. Now, we may take that the sharing. Then, it is a simple cubic unit cell. So, simple cubic. So, how many corners? There are 8 corners. 1, 2, 3, 4, 5, 6, 7 and 8. 8 corners. Now, consider this corner. Now, it is shared by how many unit cells? Listen, here one cubic corner is there. Now, we may take another cube here. So, this is shared by 2 other unit cells. Now, here one cube, correct? it is third cube, and the same way another one cube, so fourth cube. So this corner atom is shared by 1, 2, 3, 4. It is 1 half. The same way another one. We may take here 1, and 2, 3, 4. So one corner atom is shared by 8 other unit cell. That is, actually it may be present that 8 atoms out of one atom. The contribution is only 1 by 8. So here 1 by 8 and 1 by 8 and 1 by 8 and 1 by 8 and here 1 by 8, 1 by 8 and n by 8. So totally it is 8 by 8. So we may say there is 8 atoms are present in that unit cell, and one atom is contributed only 1 by 8 per unit cell. Only 1 by 8 unit cell. So we may take that number of atom per unit cell. Number of atoms per unit cell in simple cubic is nothing but number of corners. NC is nothing but number of corners, and each corner is shared by 8 other unit cells, so that the sharing is 8. So now how many corners? There are 8 corners and sharing is 8, so only 1 atom per unit cell. 1 atom per unit cell if it is a simple cubic. Now the second one we may take that is body centered cubic. Body centered cubic, BCC arrangement. Listen, if you are taken body centered cubic arrangement. So what is it? Body centered cubic arrangement. Here corner atoms are filled. In additional to corner atom, the body centered atoms are filled up. So here the corner atoms are filled up. Corner atoms are filled up. It may be atoms or ions or molecule. Now consider this is the body center, correct? This is a body center. So here the corner atom is shared by 8 other unit cell. Corner atom is shared by 8 other unit cell, and the body centered atom is exclusively 1 for 1 unit cell. It is not shared with any other unit cell. So here we may consider number of atom per unit cell. Number of atom per unit cell in body centered cubic. So we may consider that corner, number of corners, and it's shared by 8. One corner is shared by 8. And plus number of body centered, and it is shared by only 1. So 1 body centered atom per unit cell. So how many corners? There are 8 corners, and it is sharing is 8. And how many body centered? 1 and 1. So that there are 2 unit cell per 2 atom per unit cell. And here we may take that the coordination number. And listen, here each atom in a corner do not touches with each other. If it is a simple cubic, they may touches with each other. But in a body center, the corner atoms do not touches with each other. Now we may take that the coordination number. Coordination number. Now it is 1 atom. 1 atom is connected, or it is surrounding neighbor atom is 8. So it is connected with 8 neighboring atom. This is also. So 1 atom in a body centered cubic is surrounded by 8 other atoms, so that the coordination number is 8. So here the coordination number is 8. Coordination number is nothing but the number of surrounded neighbors is nothing but coordination number. Now, we may take the number of atom per unit cell, which is 2. 2 number of atom per unit cell. And each corner do not touches with each other. Do not touch with each other. But it will be touches the body centered atom. So the corner atom touches body centered atom. Body centered atoms. So this is body centered cubic.